Edebiri Ogbemundia, Doctor of Cardiovascular Physiologist. I want to put us through on the topic cardiovascular system, specifically the circulatory system. The circulatory system has three basic components. One, the heart. Two, the blood vessels. Three, the blood. The heart serves as a pump that establishes the pressure gradients needed for blood to flow to tissues. While the blood vessels is the passageway through which blood is distributed from heart to other parts of the body and back to the heart. The blood is the transport medium within which materials being transported are dissolved or suspended. Function of the heart, that will take us to the function of the heart. The heart generates blood pressure, that is routine blood. Heart separates pulmonary and systemic circulation. It ensures one-way blood flow. The heart regulates blood supply, that is changes in contraction rates and force mass blood, delivering to changing metabolic needs. Circulatory system. We have two types of circulatory system. That is the pulmonary circulation and the systemic circulation. The pulmonary circulation is a closed loop of vessels carrying blood between heart and lungs. That is for the pulmonary circulation. While the systemic circulation is a circuit of vessels carrying blood between the heart and other body system. That will take us to the blood flow through the heart. The blood flow through the heart, from the right atrium, that is the venous return from the inferior vena cava. From the inferior vena cava, blood empties its content to the right atrium, and the superior vena cava to the right atrium, and the coronary sinus. They all empty their content to the right atrium. Then from the right atrium, when blood is filled up in the right atrium, the tricuspid valves will open because the pressure has been built up in the right atrium. Once the pressure is built up, the tricuspid valves will open. When the tricuspid valves open, that will lead to the emptying of blood to the right ventricle. From the right ventricle, that is ventricular emptying. So once blood is filled up in the right ventricle, the pressure will equally build up in the right ventricle. The pressure that is built up in the right ventricle will be greater than the pressure that was initially in the right atrium. So the tricuspid valves will close. That will lead to the opening of the pulmonary seminal valves. So the pulmonary seminal valves will open, blood will enter through the pulmonary trunk and to the pulmonary artery. Through the pulmonary artery, blood will enter the lungs. So in the lungs tissue, there will be exchange of oxygenated and deoxygenated blood. The blood that was coming from the right ventricle was deoxygenated blood without oxygen. So the blood without oxygen will enter the alveoli, will exchange with the oxygenated blood. So the pressure in the partial pressure of oxygen in the alveoli will be greater than the partial pressure of carbon dioxide in the alveoli. So the oxygen will enter the alveoli, then the carbon dioxide will leave the alveoli, then it will be expelled through exhalation. Then from there, the pulmonary vein will now convey this oxygenated blood through the left atrium. So when blood fills the left atrium, the pressure gradient will equally build up. that will lead to the opening. Once the pressure in the left atrium is greater than the pressure in the left ventricle, the bicuspid valves will be meant to open. It will open, which will lead to the emptying of blood to the left ventricle. Once the pressure in the left ventricle is equally greater than the pressure gradient in the left atrium, so the bicuspid valves will close. That will lead to the opening of the aortic valves. So once the aortic valves open, the pulmonary, the aorta, blood will now enter the aorta, which will lead to the systemic supply, which is systemic circulation. So that is how blood flow all through the body. That is blood flow through the heart. Cardiac muscles of the heart. The cardiac muscles of the heart, we have the myocardium, which is the autorhythmic cell. The autorhythmic cell, it has mercury potential. This mercury potential, it never rests, which is the pacemaker, and is found in the myocardial autorhythmic cell. Then we have the myocardial contractile cell. The myocardial contractile cell have a different looking action, and it has a different looking action potential due to calcium channels. So it requires calcium channels. And we have the cardiac cell histology. The cardiac cell histology, it has intercalated disc. It allows the branching of the myocardium. Then there's equally in the cardiac cell histology, there's a gap junction, which instead of synapses that are found in the muscle cells, but the intercalated disc are found in the cardiac cell. And it has many mitochondria with a large T-tubes. Electrical activities of the heart. The electrical activities of the heart beats rhythmically as a result of action potential. It generates by itself, which is autorhythmicity. The ability for the heart to conduct its own electrical impulse is autorhythmicity. Two specialized types of cardiac muscle cells are found in the heart. One, the contractile cells, and two, the autorhythmic cells. The contractile cells has 99% of cardiac muscle cells do mechanical work of pumping. These do mechanical work of pumping. Two, normally do not initiate its own action potential. Then the autorhythmic cells do not contract. The autorhythmic cell do not contract, specialized for initiating and conducting action potential, responsible for contraction of working cell. Thank you. We'll continue from there in our next class. I remain your humble host, Edebiri Ogbemudia, your cardiovascular physiologist. Please subscribe to my YouTube channel and click to the notification button and like the video as well. Thank you for watching.